Welcome to another session in Math Mike. Don't forget to like and subscribe. Today's video, we will be focusing more on central angles. And let's start. What is central angle? In mathematics, an angle whose vertex is the center of the circle, the measurement of its angle is equal to its intercepted arc. Now let's have an example of an illustration of a central angle. Given a circle, all we need to do is identify first the center point. If our center point of the circle is represented by point O, so therefore we can name this circle as circle O. Based on the definition, angle whose vertex is the center of the circle. So therefore, if we will now create a radius and another radius, so therefore we create now a central angle. If we will be placing this point here as point X and this point is represented as point Y, therefore we can name a central angle as angle XOY. Now question, how can we determine if this is central angle? Take note, if we go back to the given question or the given statement that was provided, the vertex is the center of the circle. Observe our vertex here, the center of the circle. Direct to the point, this angle now is a central angle. Another statement in central angle, which the measurement of its angle is equal to the intercepted arc. Now, where can we locate the intercepted arc? Based on the given illustration, this is the central angle, which we can directly identify the intercepted arc of the given illustration. Its opposite arc is named as the intercepted arc. So therefore, if this is your central angle, facing arc of that angle is the intercepted arc. For example, we will be measuring this item as 110, or we'll be placing a measurement of the given central angle equivalent to 110. Therefore, arc XY is equivalent to 110 degrees. Applying the central angle theorem, angle XOY is equivalent or congruent to arc XY. So that is an example, or that is an example of a central angle. Take note, the vertex is the center of the circle, and if we will be placing measurement, it is equivalent to its intercepted arc. Now, based on the given definition, we have here the word arc. Now, let us have a short discussion about arc. In our main agenda this morning, which is the central angle, we must have an information about the different arcs. We have minor arcs, major arcs, and semicircle. Now let us know more about these following arcs. What is minor arc? Minor arc is a short arc in a circle. So this arc here, okay, the minor, is measured by a less than 180 degrees. Example, if we will be having 98 degrees as the measurement of our arc, direct to the point, that measurement of arc is a minor arc. Let's use the illustration here to represent a minor arc. For example, I will be making an illustration here. And we will be placing those points there as x and y. And our center point as point O. Now, based on the given illustration, arc xy is a minor arc. Based on the given illustration, the angle, okay, the angle is less than 180 degrees. Therefore, the item is minor arc, or the given illustration is minor arc. Now, let's proceed to the major arc. What is major arc? That is greater than, okay, greater than 180 degrees. When we say greater than 180 degrees, it is greater than the semicircle. So therefore, if we will be placing another radius here, and let us name that one as point Z. So therefore, major arc here is arc XYZ. If you observe, there is no measurement involved. There is no numerical measurement involved. But take note, our basis in identifying minor and major arc is the semicircle, which the semicircle is defined as equal to 180 degrees. Now, how will we identify a semicircle on the given figure? If you will be placing a diameter in a circle, direct to the point, the item will be called a semicircle, represented by a arc. If these points here are named as point A and point B, therefore the item now would be equivalent to arc X or AB. You can also place there as 3 points for the semicircle. You can have the answer arc A X B. Okay, so that's it. Now again, we will base only in identifying a minor arc and major arc without a measurement on the given figure, basing on the semicircle, which that is equivalent to 180 degrees. If that is less than 180 degrees, so therefore our arc is a minor. If that is greater than 180 degrees, so therefore that is major arc. Now let's have an example. Given the circle, okay, given the circle P, we have the following points in the circle: point I, point E, point A, point U, and point O. Let us name a central angle. I'll give you only 5 seconds to name as many as you can with the given illustration. Okay, time's up. Now, possibly, you identify at least, okay, two or more. You can have, for me, I can name five. Okay, so let us name a central angle on the given illustration. First central angle is IPO, angle IPO. If you answer this one, so therefore you are correct. Because again, the vertex of your angle is the center point of the circle. Another central angle is angle IPE. Because again, the vertex of the given angle is the center point of the circle. Another angle or central angle is a PU. Another is angle EPU. And many more. Okay, so again, always remember that identifying a central angle in a given illustration, always apply the rule in central angle that the vertex must be the center point of the circle and the remaining 2 points is part of the circle. Now, let's proceed to another item. What if I will be asking you for a minor arc? Can you determine or identify a minor arc on the given illustration? So I will give you only 5 seconds to identify as many as you can. Okay, time's up. So let us now identify minor arc. Arc IO is a minor arc. Basing, if you observe the given illustration, it is less than 180 degrees or less than the semicircle. Another minor arc is arc AU, which based on the given illustration, this is less than the semicircle or 180 degrees. Another arc is arc EI. Another is arc EU. And so on and so forth. Take note, identifying minor arc, you must identify it if this is less than 180 degrees or less than the semicircle. Another question from the given illustration. What if we will be identifying a major arc? How can we determine a major arc on the given illustration? Can you identify me? I'll give you only 5 seconds to enumerate as many as you can. Okay, time's up. Now, let us now try to identify if you have, okay, provided the correct major arcs. So, let's start. Arc EOU is a major arc because observing the given illustration, it is greater than 180 degrees. Another is arc AIO, which is greater than semicircle. Another major arc is UIO, because based on the given illustration, it is greater than the semicircle or 180 degrees, and many more. Okay, so that's it. Now, how about if I will be asking you for a semicircle? Can you identify me a semicircle? I will give you only 5 seconds. Okay, time's up. Possibly, if you are thinking with this given semicircle, A, E, I, so you are correct on your answer. You can also use 2 points as A, I. This is another, okay, presentation or uh, answer for a semicircle. You can have also have the answer A, U, I. So the following answers here have the same illustration, which is a semicircle. Okay, so that's it for a activity of identifying a central angle, minor arc, major arc, and semicircle. Now, what if we will be placing measurements? Let us try to solve now given those measurements. Now, let us try to solve and fill in all the measurements of the missing items there. What if you will be asked for the measurement of arc FE? What is the measurement of arc FE? Basing on the given illustration, if you observe in basic mathematics under geometry, the symbol here represents a right angle. Right angle measures 90 degrees. So therefore, applying the central angle theorem, central angle is equivalent to its intercepted arc, which is arc FE. Direct to the point, the measurement of arc FE is 90 degrees. So arc FE here is 90 degrees. Now, how about arc ED? What is the measurement of arc ED? Still the same. If we will be applying the central angle theorem, which central angle is equivalent to intercepted arc, it is still equivalent to 35 degrees. Because angle EXD is 35 degrees, therefore its intercepted arc is equivalent to 35, which is the arc ED. So this is now 35. 35. Now, what if we'll be having the angle? Okay, what is the measurement of the XC or angle DXC? Now, if you observe, line segment FB is a diameter. And we have here the symbol of a right angle. Therefore, this other side here measures 90 degrees. So if we will place here missing item, we can solve that one by applying the 90 degrees as the whole angle of the given item here. So all we need to do is add, okay, add all those items there and subtract it to 90 degrees. So we have 35 degrees plus 20 degrees, okay, and subtract it to the whole angle, which is 90 degrees. So therefore, if we add, the result is 55 and subtract it to 90 degrees. So therefore, the result is 35 degrees. So the measurement of the angle here is equivalent to 35 degrees. Now, what if you will be asking for the measurement of arc DC? Just apply the central angle theorem. All we need to do is apply that one. So therefore, angle DXC is equivalent or congruent to arc DC, which is 35. Now, how about if we will be asking for the measurement of arc AB? Okay, arc AB is still equal to angle AXB because of the central angle theorem, which is 135 degrees. Okay, so this is 135 degrees. And lastly, how about for the angle of FXA? What is the measurement of angle FXA? If you observe again, going back to the given illustration, line segment FB is a diameter. So therefore, uh, arc FB is a semicircle. If this is a semicircle, so we create now 180 degrees as the measurement of that one. So if you observe here, angle AXB is 135. All we need to do is subtract that one to 180 in order that we will get the measurement of the missing angle, which is the FXA. And the measurement of FXA is 45 degrees. Now, if this is 45 degrees, if you will be asking now what is the measurement of arc FA, so we will directly apply the central angle theorem, which they are equivalent to its central angle in intercepted arc. So we already solved now. Okay, correction, that is 45. So we already now identify all the measurements of our given illustration. Okay, given all those angles. Now let's have another example. What if there is an application of a algebra on a given problem or a given illustration? So now let us first solve, okay, the value of x on the given problem. Okay, what is the value of x given arc PS is the quantity of 5x plus 5 degrees? How to solve that one? First thing we will do is analyze the given problem. Now, if you observe, arc PSR is equivalent to 180 degrees, which is a semicircle. Okay? The given item is a semicircle. So therefore, we can get, okay, we will, yes, we can directly identify the measurement of S and P. All we need to do is add 55 and 25 degrees and subtract it to 180. So if we add 55 degrees and 25 degrees and subtract it to 180 degrees, the result is 100 degrees. Now, the measurement of S and P is 100 degrees. So we can directly now solve the S and P. If we go back to central angle theorem, angle S and P is equivalent to arc SP. So all we need to do is substitute its given value. So substitute the value of SNP, which is 100 degrees, which that is equivalent to the measurement of arc SP, which is 5x plus 5. Okay, first thing we'll do is apply the addition property of equality, which we will eliminate the 5. So we have, okay, and 5x, and the result is, okay, we'll subtract both sides by negative 5 degrees. So the result now is equivalent to 95 degrees and 5x. Then eliminate now 5. So therefore, the result is 19. So our x value is 19. Now, let us check if they are congruent. If we will substitute the value of 19, which is the x, to the given expression, which is 5x plus 5. So based on the given problem here, all we need to do is substitute. So 5 times 19 plus 5. So we have 40, mm, we have 95, okay, plus 5. So we get the 100 degrees, which they are equal. Okay, so that's it. That is if we are having a algebra or algebraic expression from the given uh, illustration. Okay, now let's have another example. What if these are the problems? Based on the given problem, we have, okay, in circle W, line segment IE is a diameter and angle IWR is equivalent to 80 degrees. What is the measurement of the following? Now, here is the solution. First thing you will do is write all the possible given item on the given illustration. So, according to the given illustration here and also the statement, IE is a diameter. So, therefore, we create a semicircle. Okay, arc EI is a semicircle. Then we have angle IWR is 80. So, therefore, this is 80 degrees. Now, we are asking for arc ER. What is the measurement of arc ER? Based on the given statement that IE or line segment IE is diameter, so therefore we can use, okay, the idea of a semicircle, which if we will be adding angle, okay, R, okay, WI, and angle, which is the missing EWR, which this following item is equivalent to an arc. Okay, so that is 180 degrees, which they are equivalent to the arc. Arc IR, if you add the arc ER, so the result is 180 degrees. Yan. That is arc addition postulate or angle addition postulate. So all we need to do is substitute all the given, and the missing would be the arc ER. So we have arc IR based on the central angle theorem. They are equivalent, and the missing, which is arc ER, and we will now eliminate by subtracting both sides by 80 degrees. So therefore, if we subtract both sides by 80 degrees, 180, subtract it by 80 degrees, the result is 100 degrees. So arc ER is 100 degrees. So arc ER is 100 degrees. Take note, we use the measurement of arc IR as 80 degrees based on the central angle theorem. Now let's proceed to arc ESI. What is the measurement of arc ESI? Based on the given illustration, uh, according to the statement, EI is a diameter. So therefore, if you connect all the points, arc ESI, we create a semicircle. So we can directly measure or place a measurement of that given problem as 180 degrees. What is the reason? We can directly place a reason that the problem is a semicircle. Now let's proceed to the number 3. What is the measurement of arc IS? Based on the given angle, which angle IWS, it has a symbol of a right angle, which the measurement of a right angle is equivalent to 90 degrees. So applying the central angle theorem, intercepted arc measures 90 degrees, which is the same measurement with the central angle. So therefore, 90 degrees is our answer. How about for arc IR? Based on the solution earlier that we apply only the theorem, which is the central angle theorem. So therefore, the measurement of arc IR is 80 degrees. Now, how about the measurement of EIR? So we have here the EIR. So all we need to do is add all the arcs. So we have here arc ESI plus arc IR is equivalent to arc EIR, which our given measurement of ESI or arc ESI is 180 degrees. Then if you added the measurement of arc IR, which is 80 degrees, so if we add the two angles there or the two measurement of the arcs, we directly solve the measurement of our arc EIR, which is 260 degrees. Okay, how about the number 6, which is the arc RES? How to solve, or what is the measurement of arc RES? All we need to do is go back to the measurement we had earlier. Based on the given illustration, arc ER, if we add this one to arc ES, we can have the measurement of arc RES, which we are looking into. So all we need to do is substitute the measurement of arc ER and arc ES, which is 90 degrees. So if you add the two angles of the given measurement of the given arcs, so all we need to do is solve and add, and we will get the measurement of its arc, which is equivalent to 190 degrees. And lastly, for the number 7, can you identify two congruent arcs based on the given illustration? Okay, if you think that your answer is arc ES and arc SI, you got it right. How can you prove they are congruent in arc? All you need to do is present the measurement of angle EWS, which is 90 degrees. Now, applying the congruent or applying the central angle theorem, which intercepted arc and central angle are congruent. If they are congruent in angle, so therefore they are still congruent in their intercepted arcs. So that's it for this problem. Now, what if we will be having algebraic expressions on the given illustration? For example, in circle O, line segment GM is a diameter and angle IOG and ROM are vertical angles. Find the following. So let us start solving the number 1. How to solve the value of x based on the given illustration? First thing you will do is analyze first the problem. If you are done analyzing the problem, so you can directly solve. How to solve? Take note, line segment GM is a diameter, so therefore arc GM is a semicircle. Based on the given illustration, if you added the arc GI, arc IL, and arc LM, we created a measurement of a semicircle, which is equivalent to 180 degrees. Then all we need to do is substitute all the given item. So substitute, take note, central angle theorem, intercepted arc is equivalent to central angle. So therefore this is x plus 3. For arc IL, we have 3x plus 2. And lastly is for arc LM, which is 2x plus 7, which that is equivalent or congruent to 180 degrees. Now, you will first simplify all the degrees of the given problem here. Okay, so we'll be having x plus 3 degrees plus 3x plus 2 degrees, okay, plus 2x plus 7 degrees, and that is equivalent to 180 degrees. Now, we'll be only combining like terms, so combine like terms, so x to x, degree to degree. So we have x plus 3x plus 2x results to 6x. 3 degrees plus 2 degrees plus 7 degrees equivalent to 12 degrees. And that is equivalent to 180 degrees. Then all we need to do is operate. Okay. Now we have here 6x is equivalent to 180. Subtract it by 12 degrees. Then we have 6x is equivalent to, if you subtract that one, the result is 168. Then we will now divide both sides by 6 to eliminate the value of 6, and in order that we can solve directly the value of x. So if you divide that one, it results to 28. Now, let us now try to solve or substitute in order that we can prove that they are equivalent in 180 degrees. So let us substitute the value of x. So 28, okay, plus 3. The result here is 31 degrees. Okay, how about for the next item, which is 3x? So all we need to do is substitute 28. Okay, so we have 2. Okay, so we have 84. Okay, plus 2. And the result is 86. And lastly, for 2x plus 7, all we need to do is substitute. So we have 2 times 2x, 28 plus 7. Okay, so this should become 56 plus 7. And the result is 33. No, not 33. That is 63. Okay, so if you added all the result there, 63 plus 86 plus 31 is equivalent to 180 degrees. So therefore 28 is correct. So the value of x is 28. Now let us proceed to arc IL. Based on the given solving that we had, we have the value of x. So all we need to do is substitute and we got the result, which is the 86 degrees. So therefore, applying the central angle theorem, the intercepted arc is equivalent to 86 degrees. So therefore, the measurement of arc IL is 86 degrees. Now, how about for arc IG? So still, we have the value of x. All you need to do is substitute, and we already done, okay, in substituting the value of x, and the result is 31. So applying the central angle theorem, opposite or intercepted arc is equivalent to the central angle. So therefore, our value of arc IG is 31. Now, how about arc MRG? Take note, based on the given statement, that line segment GM is a diameter, so arc MRG is a semicircle. So the measurement of a semicircle is equivalent to 180 degrees. Now, next, how about for the number 5? Okay, correction for that item. That is number 5 and number 6. So for our arc MR, take note the given statement here that angle IOG and ROM are vertical angle, which take note if we go back on the definition of vertical angle are congruent angles. So, basing on the given measurement here, we have 31. So, therefore, angle ROM is still 31 degrees. So, applying the central angle theorem, if the value of central angle is 31, so therefore the intercepted arc is also 31 degrees. So the value of arc MR is 31 degrees. And lastly, for GOR or angle GOR. Now take note, arc GRM is a semicircle. So if we will only subtract the measurement of angle MOR, which is 31 degrees to 180 degrees, so therefore we will get the measurement of angle GOR. And the result is equivalent to 149. So angle GOR is equivalent to 149 degrees. Okay, so that's it for this day. Hope that you understand and hope that you learned something this morning.